This is question number 1.2 of Rk Patharia, and in this question we have given that entropy S and statistical number of a physical system are related through functional form S equals to omega is the arbitrary statistical number and S is functional. That the additive character of S and multiplicative character that the function f omega be the form 1.2.6. So what is 1.2.6? So if you check Rk Patharia, then according to Rk Patharia, 1.26 is S equal to K ln omega. So we have to prove this via this property. So what is additive character of S? Additive character of S and multiplicative character of omega means that if I take f of omega 1, omega 2, statistical number, then the entropies get added plus 2. This is S1 plus S2, and this is the entropy of the whole system is S1 plus S2. How we will solve this question? So this question can be solved. Suppose I will differentiate this. So df of omega 1 omega 2 with respect to omega 1, and this is f of omega 1 over omega d omega 1. With respect to omega 2, if I differentiate, then it will be 0. Now see, I have to that firstly differentiate df omega 1 omega 2 over the argument of this function, and then differentiate this argument with the one with respect. So I will get omega 2. Now similarly this will be f of d omega 1. Now see short form like f dash omega 1 omega 2 is written like this f dash. It means that this function is differentiated with respect to argument. Here the argument is omega 1 omega 2 into omega 2. Here the function is with respect to its argument differentiated, so it can be written in the short form like this. So similarly f dash omega 1 omega 2 f dash omega 1. Now let me differentiate this function with respect to omega 2. So similarly df of omega 1 omega 2 over d omega 2 equals to, and this is what? This is will be 0 and d f 2. Now I will apply chain rule. I will differentiate this function with respect to firstly with respect to its argument, which can be written as f into this omega 2. So this will be omega 1 and this will be f dash. Its argument is omega 2. So I can write f dash omega 2 will be f dash omega 2 divided these two, this one and this one, and f dash omega 1 omega 2 is equal to f dash omega 2. So what will I get? I will get f dash omega 1 omega 1 equals to omega 2 f dash omega 2. Similarly, if I have take n systems, then it will be like this n f dash dn. So I can write omega f dash will some constant k. Okay, so now I will solve this equation, this differential equation, and I will get the answer. We solve it here. So it will be omega f dash omega equal to omega, this is k divided by omega, and so my f will be k ln omega plus constant. Now this, so I can put, so this is its function of f of omega equal to k ln omega. Okay, now so now I can find the value of c via this. So suppose I find f of omega 1 omega 2, then what will be this? This will be k ln omega 1 omega 2 plus c. So this f of omega 2 k ln omega 1 plus k ln omega 2 plus c. Now if I come must be 0, because f of omega above f of omega 1 omega 2 is k ln omega 1 plus k ln omega 2. There is no c, so c must be 0. Functional form should be k f equal to k ln omega. Hence proved. Okay, thank you very much.